All right. Before I start solving the questions from today, I want to bring your focus back to one of the questions we've solved earlier. So here we are talking about a traction device, and the entire point of this device is to keep everything in equilibrium. So that's what we will assume. Everything is at rest. Nothing is moving, right? So let's start with the free body diagrams. First, I'll name everything. This is my block. This is my small pulley. And this is my, let's call it my harness, right? So for the block, the forces that are acting on the block are mg in the downward direction and tension T, or in this case it's T2 in the upward direction. For my small pulley, I have two tensions, T1 and T2, right? And then it's connected to the harness. So let's say it applies a force P on the harness. What I will do now is because there are multiple forces in different directions here, I will define my x and my y axis. So this is my plus x, this is my plus y, right? I should maybe put it in the same figure. So that is my plus x, and that is my plus y. All right. Now, let's look at the harness. So at the harness, excuse me, if that is my harness, the pulley is applying a force P, or it is pulling it with a force P, and then we are told that there is a force F acting on it because of the weight of the leg, right? So these are my free body diagrams. Let's look at my forces now. So for the block, summation of f of y is equal to T2 minus mg. This is generally equal to m times a net, but because everything is at rest, at equilibrium, my a net is 0, so it becomes 0. So rewriting this equation, T2 is equal to mg. All right, now let's look at the the small pulley. At the small pulley, summation of f of x gives me, so remember this is my x direction, and the angle is 30 degrees. So this is 30 degrees and that is 30 degrees. So in the positive direction, I have t1 cosine 30 plus t2 cosine 30. And then in the negative direction, I have p. Again, things are not moving, so I can say all of this is equal to 0. t1 cosine 30 plus t2 cosine 30 minus p. So p is equal to t1 cosine 30 plus t2 cosine 30. Now let's look at the y direction. In this direction, this is positive, so t1 sine 30 minus t2 sine 30. This should be equal to 0. So t1 sine 30 is equal to t2 sine 30. Sine 30, sine 30 cancel out. So t1 is equal to t2. Taking this, but this is equal to mg. Right? Putting all of this into my equation for p, I get p is equal to mg cosine 30 plus mg cosine 30 is equal to 2 mg cosine 30. Let's look at the harness now. Now in the harness, there are only two forces, and if this particular harness is in equilibrium, they both have to be in the same axis, right? They have to be in the same, they have to be along the same line. So summation of f of x, because I just assumed this is x, is equal to p minus f. If nothing is moving, this is equal to 0. So f is equal to p, which we know from here is equal to 2 mg cosine 30. The value of m is 2.27. 2 times 2.27 times 9.81 times cosine 30. Quickly solving this gives me 9.81 times cosine 30 gives me 38.57 newtons. Let's look at the significant figures. So it technically should be 38.6 newtons. Right? Next question. A person tosses a ball for her puppy to retrieve. The ball leaves her hand horizontally with a speed of 4.6 meters per second. So this is the ball, that's the velocity initial. If the initial height of the ball is 0.95, so let me draw the ground. That is 0.95 meters, and v0 is equal to 4.6 meters per second. So the trajectory of the ball Should be something like that. So if this is my x naught equal to 0, this should be my x naught equal to r, just because. This is my y naught equal to 0. This is my y final equal to, y naught is equal to 0.95 meters, and y final is equal to 0 meters. So let's solve that. I need to first find how quickly does this particular ball reach the ground in the y direction. So I have my y final, I have my y initial plus v0 y times t plus half times a t squared. Now this is 0, y initial is 0.95, v in the y direction is 0, because this is completely in the x direction. This is 0 plus negative 9.81 divided by 2 t square. So t square is equal to negative 0.95, and then this is negative 9.81 divided by 2. So t square is equal to 0.95 times 2 divided by 9, negative 9.81. Negative cancels out. Multiplied by 2 divided by 9.81. T square is equal to 0.1936, and then taking the square root on both sides, t is equal to 0.44 seconds. Now to find the range r, I use the same equation. I use x final is equal to x initial plus vox times t plus half times a t square. Substituting the values, 0 plus it's 4.6 meters per second times 0.44 plus half times 0.44 square. So this is just equal to 4.6 times 0.44, 0.44 times 4.6. This is equal to 2.024 meters. And looking at the significant figures, so that's 2, there should be only 2 here. So yep, that is my answer. Right, next question. A tennis serve, 0.07 kg ball can be accelerated from rest to 36 meters per second. Or a distance of that. Okay. Find the magnitude of the average force exerted by the racket on the ball during the serve. All right. So during the serve, it goes from v initial 0 to v final equal to 36 meters per second. X initial 0, x final is equal to 0.75 meters. So using the equation, v final squared is equal to v initial squared plus 2a times x final minus x initial, which is delta x. So final is 36 squared 0 squared plus 2a, x final is 0.75 minus 0. So rearranging the equation, 2a is equal to 36 squared divided by 0.75, and then I'll also move the 2 on the other side. So quickly doing the calculation, I get this as my meters per second. So now that's my acceleration. So force is equal to mass times acceleration. Now they're asking us about the average force. I can definitely say that this is the average force because the acceleration should be constant. I assume the acceleration is constant to apply this equation. This equals 0.070, all right, times 3, 4, 5, 6. Multiplied by 0.070. So the value I get is 241.92 newtons. Let's look at the significant digits. Everything is 2. So I'll say this is 2.4 times 10 raised to 2 newtons. All right, next question. All right. So two blocks are connected by a string. The smooth inclined surface makes an angle 42 degrees with the horizontal. And the block on the incline has a mass of 6.7 kg. Find the mass of the block M that will cause the system to be in equilibrium. All right, perfect. So again, it's a free body diagram is where we start first. So for block with a mass M, gravity in the downward direction, mg, and tension in the string in the upward direction. For the block on the incline, again you have, I'll call it capital MG. This is capital M. That's theta. That's T. That's T. So T is along the incline, and then there's a normal reaction force perpendicular to T, or perpendicular to the surface, right? So now let's figure out the angle. This is theta. So this should be 90 minus theta. If that's 90 minus theta, this should be theta. All right. So now looking at the forces for the block on the incline, just a second, I'm trying to see if they want us to use friction. They haven't mentioned friction. Oh, it's smooth inclined surface. Perfect. So no friction. Summation of f of x. What direction is x? I did not mention the direction of x. So this is positive x, and this is positive y. Summation of f of x is t minus component of mg in the x direction, which in this case is this. It's opposite of theta. Opposite of theta is sine. Perfect. Now we know this system is not moving, it's in equilibrium, so it's equal to 0. So t minus mg sine theta, so t is equal to mg sine theta. Can we find the value of this? I think we can, because we know the value of capital M, we know the value of gravity, and then we know the value of theta. 6.7 multiplied by 9.81 multiplied by sine 42. This equals 43.98 newtons. I'm not concerned about the significant figures right now. So let's look at block M. Summation of forces in the y direction, because I'm just assuming that is positive y. The y direction is t minus small mg. It's not moving, so it's 0. T is equal to 43.98 minus mg. Bringing mg on this side, it's 43.98. So now small m is equal to 0.98 divided by 9.81. This is equal to 4.48 not newtons, kg. And let me look at the significant figures. There's only 2, so this becomes 4.5. All right, and that is the question. Find the mass of the hanging block. Next question. A small motor runs a lift that raises a load of bricks weighing that to a height of 10.7 in 23.2 seconds. Assuming the bricks are lifted with a constant speed, what is the minimum power the motor must produce? All right, I do not remember the formula for power, so let me just quickly look it up. And for that, I will use the equation sheet that will be provided in the exam. Okay, power is equal to work by time. I know work is force times distance. Here my F is equal to 836 newtons. My distance traveled is equal to 10.7 meters. Time is equal to 23.2 seconds. So in an ideal situation, the amount of power this particular motor has to generate in order to lift this load will only be whatever the result is here. $385.57. I think this is watts. in the real life it'll have to produce more than this particular thing. So P real will have to be greater than 385.57 because there are losses in the real life, but in an ideal situation there won't be any losses, so this is the only amount of power it'll have to generate. Right, next question. A particle moves under the influence of a conservative force. We're not told what conservative force, but we know that if it's a conservative force only, then our energy is conserved. So it goes from point A, where it has a kinetic energy of 12 joules. We don't know what the potential energy is here. It goes all the way to point B, where it is at rest. So the kinetic energy is 0 and the potential energy is given as 25 joules. Then it goes to point C, where we again don't know the kinetic energy, but the potential energy of the system is 5 joules, right? The question is, what is the potential energy of the system when the particle is at point A? So one thing I can say is the energy at A is equal to the energy at B is equal to the energy at C. So the kinetic energy at A plus the potential energy at A is equal to the kinetic energy at B plus the potential energy at B. Kinetic energy at A is 12. We don't know the potential energy at A. Kinetic energy at B is 0. Potential energy at B is 25. So I can calculate the potential energy at A using this equation is equal to 13 joules. Now there are other parts to this question as well, but we are not going to solve all of that. We can definitely solve for the kinetic energy at C, right? So if I just do the quick calculation, at C plus the potential energy at C is equal to the kinetic energy at B plus the potential energy at B. So this is something I don't know. Plus 5 is equal to 0 plus 25. So kinetic energy at C should be equal to 20 joules. Perfect. All right, next question. So here a meteor strikes a car, creates a dent of 22 centimeter deep. Its initial speed is equal to 550 meters per second. It comes to a stop, of course, finally. So its final speed will have to be 0 meters per second. And it created a dent of 22 centimeters. So if I consider my x0 as 0, then my x final is 22 centimeters, which is equal to 0.22 meters. Now can I calculate the acceleration of this particular instance? So I'll just go v final squared is equal to v initial squared plus 2a x final minus x initial. So v final is 0, v initial is 550 squared, right? 2a times 0.22 minus 0. So 2a times 0.22 is equal to negative, or maybe I should say is equal to negative 550 squared. So a is equal to negative of 550 squared divided by 2a. Oh, 2 times 0.22. So what is the value here? 50 squared divided by 2 divided by 0.22. I get negative 687,500. So that's because if this is the car and this is the meteorite, it created a dent and the car stopped it. So its velocity was in this direction. Velocity was downwards, and the car's the surface provided a force in the upward direction. Right? So the acceleration is opposite to the velocity. So because we selected the velocity as positive, the acceleration is negative. So average force now is equal to my mass times acceleration. My mass is 27 pound. Let me convert 27 pounds to kgs first. So 27 pounds is equal to 12.247 kg. I'll do the significant figures later. 12.247 times 687,500. I can say it's negative, but then the force and the acceleration will have the same direction. Multiplied by 12.4247. Alright, so the value I get is 841,981.12.5 newtons. And now looking at significant figures, this is only 2 significant figures. This is 3. So technically I should have only 2 significant figures. This is negative 8.4 times 10 raised to 6 newtons. And that's my answer. Right, next question. So a 6.6 kg block slides with an initial speed up a ramp at an angle with the horizontal. The coefficient of kinetic friction, because it's moving, between the block and the ramp is 0.44. Use the energy. Okay, so first let's draw the situation. If that is my ramp and this is my block that's moving up, it has a mass m. The forces acting on it are mg, normal reaction force, and because it's moving up, it has a kinetic friction Fk. So first, Fk is equal to mu k times n. Because it's kinetic friction, that is its formula. That is the way you find out kinetic friction. That's it. To find n, I will do summation of forces in the y direction. That's positive y. So n minus, let's look at, if this is theta, again, if that is theta, this is going to be 90 minus theta. So that is theta. Theta, so mg cosine theta. It is moving. Is moving up. So what I should do, if it is moving up, it'll have an acceleration. Let's look at its energy, because we are asked to use energy conservation. So if this is its initial position and this is its final position, from this point to this point, it will have moved a little bit higher up. So this is its change in height. Here its velocity is 0, and here its initial velocity is given here as 2.24 meters per second, and its height is 0, because that's where I'm assuming this is 0 and this is h. So initial energy is again mgh plus half mv initial squared. So initial height is 0, so 0 half m v initial squared. Final energy is equal to again mg h final plus half mv final squared. So h final is h, so mg h. Final velocity is 0, so 0, because the block has to come to a stop. They are asking us to find the distance the block slides before coming to rest, so it has to stop. All right, so because there is friction, there is non-conservative work. So non-conservative work is equal to its initial energy minus final energy. So initial energy is half mv initial squared. Final energy is mgh. The work done here should be equal to friction force times the distance traveled. And the friction force should be equal to nu k n times d mv initial squared minus mgh. And now I need to figure out how much friction is acting on this. So this particular object is moving in the x direction. So this is positive x, this is positive y. So it shouldn't have any acceleration in the y direction. It's not moving in the y direction. So I'll write that down again. Is equal to n minus mg cosine theta. This should be equal to 0 because there's no acceleration in the y direction. So my n is equal to mg cosine theta. So substituting that here, I get mg cosine theta times d is equal to half mv initial squared minus mgh. So m is common throughout, so m gets cancelled out. And what I'm asked about is d. So let's keep d as it is. Now h can also be converted into d, because that's my theta, that's my h, and that's my d. So h is equal to d sine theta. So substituting that here, perfect. Now I'll bring this to the other side. D plus g d sine theta equal to half vi squared. Taking d common, you get mu k cosine theta plus g sine theta to half vi squared. Oh, I missed a g here. So d is equal to vi squared divided by 2 times g. I just took g common, so mu k cos theta plus sine theta. Substituting the values, so speed is 2.24 squared 2 times 9.81 times the coefficient of kinetic friction is 0.44 times cosine of the angle is 18.4. Putting all this in the calculator. .44 cosine of 18.4 plus sine of 18.4. The value I get is 0.35 meters. And that's the answer, I think. Hope the processes here made sense. Hope the steps I took made sense, and hope you can do these problems on your own in the test now. All right.